So I think it'd be worth it then if we touch more on what oxidative stress actually is. Would you mind, Dr. Levy, going into a bit of the science behind what oxidative stress really is?
Well, oxidative stress is probably not used this way in the literature, but the literature does say with any disease that you can find, type in any disease that you can think of in PubMed, whatever, diabetes, high blood pressure, whatever, and then oxidative stress. And you're going to see a whole host of articles showing that there is increased oxidative stress in those diseases. But they consider it a correlation or association, this, that, or the other. No, it's cause and effect. Once again, the primary idea is that it's called redox biology, reduction oxidation biology. And again, it's based on the fact what I just said is that all disease is oxidation. Now, that's not to say that oxidation is always bad. Your normal physiology generates oxidation, and that's what you call a physiological level of oxidation. But that low level is important because it triggers things to react and bring reduction in antioxidants back in. But when the balance gets skewed, when the antioxidant level gets low and or the toxin level gets high, pro-oxidant, you have a poorly functioning cell because too many of the biomolecules are oxidized. It's that simple. And also important are synonyms. Toxin equals pro-oxidant equals free radical equals reactive oxygen species equals poison. They all mean the same thing. When you get poisoned by something, it means the toxin chemical configuration caused it to focus on a specific area that was very critical to your health acutely. I mean, you can inhale the mercury vapor from your fillings all day long and not clearly have a problem until maybe you develop multiple sclerosis or congestive heart failure 20 years later. But it's still oxidative stress is doing that. On the other hand, if you inhale hydrogen cyanide in the nose, it just because of the chemical nature of the toxin, it goes directly into the respiratory cells that utilize oxygen, oxidizes or poisons those enzymes so that you can't pull oxygen in anymore. And obviously, if you can't pull oxygen in, you die in a minute or two. But it's still oxidative damage and nothing else.
Very interesting, very fascinating.
Incidentally, anybody that's listed, I have a whole list of articles, and I have no problem at all with people sending me a request to my email, televy@yahoo.com, and I'll give them a whole list of these articles, well documented. That's not me saying stuff crazy that's not in the literature. It's just, to the best of my knowledge, the literature has never been coalesced and correlated in this fashion. And there's also 3 or 4 books that I offer the public as ebooks for free if they want.
Fantastic. I think what will be useful as well is that if we just link them below in the description box, Dr. Levy, if you email me those links, and I'll put them in the description box, and everybody got access to them straight away. So if they want them, it's all there. So I've also been told then that methylene blue. So we've touched then on what methylene blue can do for the cell. So we can skip that 4-phase process, right, of the cell, go right to the front, and then provide all the benefits. I've also been told that methylene blue is also a heavy metal detoxifier. Is that correct, or is that not true?
Well, I don't know that I've run into literature that specifically asserts that, but I will say any powerful antioxidant that gets everywhere it needs to go in the body, well, guess what an antioxidant does also? Once it's inside your cell, if you have toxins inside your cell, it increases oxidation inside your cell, and your enzymes that help you eliminate toxins are oxidized. When you oxidize an enzyme, you render it useless. You no longer have an enzyme function. So to the degree then that it can reduce critical antioxidant enzymes and chelation type enzymes, yes, I don't know that it has a direct chelating effect, but I'm certain it has a toxin mobilizing effect so that, potato, potato, tomato, tomato, I think you're still getting definitely a chelation effect. Yes.
Yeah, that's good to know because I mean, we're bombarded now, aren't we? Really, with heavy metals in all forms, in different ways, pesticides from our food, and
Well, one thing
the
I
level
noticed
of
when I wrote the paper on cardiomyopathy, remember I told you that in addition to having 22,000-fold more mercury in the heart, you had 1,100-fold more antimony. Well, who talks about antimony? Well, it's also a toxic heavy metal, and one of its major sources is plastics. So what are we doing all day long? Now, I'm sure there are some plastics that are safe. I don't know which one they are. I can't give you a breakdown on the different construction of German plastics to tell you which ones do, which ones don't. Maybe they all do. I don't know. But a lot of antimony in the plastics. So you have water bottles of this, whether we're sucking. Go with glass. Go with glass. Go with glass. Okay. They had a fascinating article, Reese, and I don't know what caused them to think about it. Maybe because they were getting crazy results and they had to recheck it. They were testing blood of patients for antimony. And they collected the blood in the plastic container and the blood in the glass container. And the one in the plastic container, which it doesn't sit there that long, remember. You draw blood, and it sits there a while, and then you go run it. It doesn't sit in that vial for days, weeks, months, or years. And there was substantially more antimony in the blood that was collected in the plastic vial than the glass vial. So this is something that I don't think anybody's been addressing. But gosh, if you have over 1,000-fold more of something inside a tissue that's failing, I think we should consider that a toxic effect.